Hello students, so I welcome you for the sixth lecture in analog communication. So in last lecture we have discussed the basic concept of the baseband signal and carrier signal. Also we have seen the baseband communication system and carrier communication system. We have also covered the basic concept of modulation and demodulation. So I hope you are clear with that. So in today's lecture we are going to see the basic types of the modulations. So modulation means what that we have seen. So just I have taken here the review of the syllabus. So syllabus, first chapter syllabus, it is given here. In that the points which we have completed are introduction of communication, elements of a communication system, baseband and carrier communication, and then modulation and demodulation. So we have just taken overview of modulation and demodulation, but we are having the basic experiments based on amplitude modulation, frequency modulation and phase modulation. So from experiment point of view also, we have to theoretically first clear with the sub points what are there in the modulation. So there are basically which types of modulation that we are going to see in this lecture, and then we will go for need of the modulation. Okay, so we have seen that modulation requires two types of signals, analog signal and digital signal, or basically the modulation requires two types of signals, carrier signal and the modulating signal. So characteristics of carrier are changing in proportionate with characteristics of the modulating signal. That is the concept of the modulation. So if we see the modulation, it is basically divided into two types. First, try to understand what are the different types of modulations. Basically जर आपण बघितलं modulation मध्ये, तर there are two types of the modulation methods. First one it is analog modulation, and second one it is the digital modulation. So what is the concept of analog modulation? Both the modulating signal as well as carrier signal are in the analog form. That is the concept of analog modulation. Carrier signal and modulating signal, both the signals are in the analog form. That is the specification of analog modulation. And digital modulation means what? Either one signal is in the digital form. So it can be the modulating signal or it can be the carrier signal. दोन्हीपैकी एक कुठला तरी सिग्नल जो असतो, that is in the form of the digital signal. That is the concept of the digital modulation. Then right now we are not going to consider about the digital modulation. We are going to just consider about the analog modulation. So let us read these 3 points or 3 concepts of analog modulation techniques. 3 methods are there in analog modulation. First one is amplitude modulation, second is frequency modulation, and third one it is the phase modulation. So we will see one by one what are the concepts and what are the waveforms for the respective points. So first we will see what is the difference in AM, FM and PM. Now whatever are these modulation methods, those are abbreviated as AM. Amplitude modulation is noted as AM, frequency modulation is noted as FM, and phase modulation is noted as the PM. So these are the 3 basic types of analog communication or analog modulation methods. So what is the basic concept of these 3 modulation methods that we will see now. So let it be any type of modulation method. What is the basic concept in that? That in any type of the modulation, what is the thing? That characteristics of, or I will write, characteristics of carrier signal are changing in proportionate with the modulating signal. मग ह्या तिन्हीपैकी कुठलंही मॉड्युलेशन असलं तरी always our characteristics of carrier are changing in proportionate with characteristics of the modulating signal. So in amplitude modulation what happens? I am writing the concept. In amplitude modulation, amplitude of the carrier changes, and when the amplitude is changing, phase and frequency remains constant. Only amplitude of the carrier signal is changing and phase and frequency of the carrier signal remains constant. That is the concept of amplitude modulation. Next is frequency modulation. So what will happen in frequency modulation? Frequency of the carrier changes in proportionate with modulating signal. Here also amplitude is changing in proportionate with the modulating signal. So these parameter changes with respect to modulating signal. Here in FM, frequency changes in proportionate with modulating signal, and amplitude and phase remains constant. Amplitude and phase remains constant, only the frequency is changing. That is the concept of frequency modulation. And the next concept it is of phase modulation. So in phase modulation, only phase of the carrier changes. How it is changing, that we will see in the waveforms. Here just understand, phase changes with respect to modulating signal, and when phase is changing, frequency and amplitude remains constant. तीन पॅरामीटर आहेत, लक्षात घ्या, ॲम्प्लिट्यूड, फ्रिक्वेन्सी आणि फेज. ॲम्प्लिट्यूड मॉड्युलेशनमध्ये ॲम्प्लिट्यूड चेंज होतं, फेज आणि फ्रिक्वेन्सी कॉन्स्टंट राहते. फ्रिक्वेन्सी मॉड्युलेशनमध्ये फक्त फ्रिक्वेन्सी चेंज होते, ॲम्प्लिट्यूड अँड फेज रिमेन्स कॉन्स्टंट. And in phase modulation, only phase changes, frequency and amplitude remains constant. That is the basic concept of AM, FM and PM. मग कशावरून पडलेत हे तीन टाईप? These three types are derived from, or these three types are based on which parameter of carrier it is changing in proportionate with modulating signal. When amplitude changes, it is called as amplitude modulation. When frequency changes, it is called as frequency modulation, and when phase changes, it is called as the phase modulation. That is the difference between AM, FM and PM. Okay, I hope all of you are clear with that. Now we will see how to draw the waveforms for this particular types of modulations. But before going to the drawing of the waveforms directly, we will first see that what are the some other theoretical things given about this AM, FM and PM. So same thing it is given here. Amplitude modulation is a kind of modulation where the amplitude of the carrier is changed in proportionate with the message signal. Means it is changed in proportionate with the modulating signal. Frequency and phase of the carrier signal remains constant. Frequency modulation मध्ये काय होतं? It is the process in which frequency of carrier signal it is changed in proportionate with modulating signal, whereas the phase and amplitude of the signal it is kept constant. That is the concept of the frequency modulation. Then what is the concept in phase modulation? In case of phase modulation, phase of the carrier changes with respect to modulating signal, and frequency and amplitude remains constant. So these are the basic types of the analog modulation methods. Now we will see how to draw the waveforms for this particular. So before I draw it on paper, just have a look for these diagrams, how the diagrams look for amplitude modulation, frequency modulation and phase modulation. compare that what is the difference in their waveforms AM, FM and PM. Just have a look for these three diagrams for a minute. First one is of amplitude modulation, second is of frequency modulation, and third one it is of the phase modulation. So in any type of modulation we have taken same modulating signal and same carrier. तिन्ही डायग्राम मध्ये modulating signal आणि carrier signal तेच ठेवलेले आहेत. Only the changes in the resultant modulated signal AM, FM and PM. Okay, so this first diagram is for amplitude modulation signal, then second it is for this frequency modulation, and third one it is for the phase modulation. Now we will see how to draw the waveforms for this particular modulated signals. So as per the sequence, actually first one it is the AM, but AM we will keep at last because it is somewhat difficult to draw, or not difficult exactly, but it is somewhat critical to understand the waveform of AM. So we will not take first the waveform of AM, we will first complete the waveforms of frequency modulation and phase modulation. So we will see how to draw the waveforms for FM and PM. Okay, pay attention here carefully, because these are the diagrams which you have to frequently draw in the exam as well as you have to draw in the journal. So for frequency modulation ची diagram काढतोय आपण, which is abbreviated as FM. So what is the first signal required in frequency modulation? The first signal required is nothing but the modulating signal. Okay, you indicate the frequency of the modulating signal as FM. On x-axis it is time and on y-axis it is voltage. That is the concept of modulating signal. Let us say this is minus 2 volt and this is plus 2 volt. Positive plus 2 volt and negative minus 2 volt. So this is the modulating signal. Then what is the next signal we require, or I will write here. First कुठला signal काढला आपण इथं? First we have drawn the modulating signal or baseband signal or information signal. Now second signal required for the modulation, it is the carrier signal. So we will draw the concept of carrier. As I have explained you, carrier signal काढताना काय दिसायला पाहिजे? दोन्ही मधला frequency difference that must be noticeable to our eyes. That is the concept of the carrier signal. Carrier signal मध्ये काय होतं? Both are in the analog form. Only amplitude काय ठेवलं आपण इथं? Amplitude we have kept same. FM मध्ये amplitude ची कुठलीही कंडिशन नसते. कॅरियरचं amplitude हे मॉड्युलेटिंग पेक्षा कमी असू शकतं, जास्त असू शकतं किंवा इक्वल असू शकतं. Let us say it both are same. So this is of the carrier signal. Now this is also having time on x-axis, voltage or amplitude on the y-axis, and this is the waveform of modulating signal and the carrier signal. Now we have to draw the diagram for frequency modulated signal. आता frequency modulated signal चा concept काय? What happens in frequency modulation? Frequency is changing, phase and amplitude remains constant. Only frequency is changing, phase and amplitude of the signal remains constant, same as that of which signal? It will remain same as that of the carrier signal. Always remember, modulated signal जो आहे त्याच्या सगळ्या characteristics ह्या carrier सारख्याच असतात, except which modulation we are considering. So now we are considering the frequency modulation. So only there will be change in the frequency of the carrier signal in the modulated signal. हा modulated signal म्हणजे it is nothing but it is same as the carrier only. Only few parameters of carrier are changed in proportionate with this modulating signals, positive half cycle and negative half cycle. So let us see for what happens in FM. So in frequency modulation, what is the concept? I will write here. In FM, when the positive half cycle is there, frequency is increased. So already I am explaining, so writing in short. For the positive half cycle of this modulating signal, the frequency of FM increases for the positive half cycle, and for negative half cycle of this modulating signal, the frequency of the FM frequency of the carrier signal it is reduced. That is the concept of frequency modulation. किंवा सिम्पली लक्षात ठेवा FM मध्ये काय होतं, पॉझिटिव्ह हाफ सायकलला फ्रिक्वेन्सी वाढते आणि निगेटिव्ह हाफ सायकलला फ्रिक्वेन्सी कमी होते. सो हियर इफ वी हॅव टू ड्रॉ फॉर दिस पॉझिटिव्ह हाफ सायकल द फ्रिक्वेन्सी ऑफ द सिग्नल इज okay, I will draw it with proper scale. For positive half cycle, the frequency of the signal it is more, and for negative half cycle, the frequency of the signal it is less. That is the concept of the FM modulation. Frequency ही positive half cycle ला जास्त असते and here it is less. So the how your FM waveform will look, I have not it drawn by exact scale, that I will explain on that in that PPT. Just understand the concept here. For जेव्हा मॉड्युलेशन नसतं तेव्हा कॅरियरची फ्रिक्वेन्सी ही कॉन्स्टंट असते. सपोज से दॅट FM is equal to 1 kilohertz, then here FC is equal to, in this case FC is equal to 15 kilohertz. Then before modulation, everywhere in this waveform value of this frequency it is 15 kilohertz. So what happens here in the FM modulation, for positive half cycle frequency it is more. So I will say in this portion from this point to this point frequency it is more, and from in between this portion the frequency it is less. That is the concept of frequency modulation. So I hope all of you are clear with the concept of frequency modulation. In this way you have to draw the diagram in the exam. So here the same diagram it is given for frequency modulation. Here if you consider, this is the positive half cycle, or this is the modulating signal positive, and this is the carrier signal. or positive half cycle of modulating signal FM ची frequency increase झालेली आहे, and for negative half cycle of the modulating signal the frequency of FM signal it is reduced. That is the concept of FM, and I have explained how to draw the diagram for the frequency modulation. I hope all of you are clear with that. The diagram, how to draw the diagram for frequency modulation. Now the next type of modulation, that is the phase modulation. So if we have to see the next type of modulation, that will be nothing but the phase modulation. So in phase modulation what happens? In phase modulation, phase of the carrier is changing. So in in phase modulation, phase of the carrier is changing. I am writing here, phase of the carrier is changing, whereas frequency and amplitude remains constant. Resultant जो आपला फेज मॉड्युलेटेड सिग्नल आहे त्याची ॲम्प्लिट्यूड आणि फ्रिक्वेन्सी काय राहते, कॉन्स्टंट राहते, अँड देर इज ओनली चेंज इन द फेज ऑफ द कॅरियर सिग्नल. सो सेम डायग्राम वी विल ड्रॉ हियर नाउ. Same signals we will take. So first we have to take the modulating signal. So this is the modulating signal. Let us say this FM is equal to 1 kilohertz. Here it is voltage, here it is time. So let us consider this is plus 2 volt and this side it is minus 2 volt. So this is the concept of modulating signal waveform. Now another waveform we have to draw. What is the another signal that we have to draw? After drawing the modulating signal, suppose this is diagram A. A ही कशाची diagram आहे? Modulating signal. Then after drawing the diagram of modulating signal, what we have to draw next? We have to draw the diagram of the carrier signal. So when we have to draw the diagram of carrier signal, just consider that FC, again as same we have done, frequency of this carrier signal is very high as compared with frequency of the modulating signal. So frequency of the carrier is very high as compared with the modulating signal. Then we have to draw now the waveform of the phase modulated signal. So we will see how the diagram of phase modulated signal will be there. But I will explain the concept for one cycle. After that we will increase the number of cycles so that you can understand the concept of phase modulation properly. आता फेज मॉड्युलेशनमध्ये किंवा कुठल्याही मॉड्युलेशनमध्ये डायग्राम काढताना व्हॉट यू हॅव टू डू फर्स्ट, यू टेक द प्रोजेक्शन्स ऑफ दिस पर्टिक्युलर पॉईंट्स एक्झॅक्टली ऑन दिस थर्ड एक्स ॲक्सिस. जिथं आपल्याला मॉड्युलेटेड सिग्नल काढायचं आहे तिथं आधी काय करायचं, टेक द प्रॉपर प्रोजेक्शन्स ऑफ दिस पर्टिक्युलर पॉईंट्स ऑफ मॉड्युलेटिंग सिग्नल. कारण FM असू द्या, फेज मॉड्युलेशन असू द्या, AM असू द्या, there are the boundary conditions where the parameters are going to change. आणि ह्या सगळ्या बाउंड्री कंडिशन्स आहेत जिथं पॉझिटिव्ह हाफ सायकल संपतं, निगेटिव्ह चालू होतं, किंवा जिथं निगेटिव्ह हाफ सायकल संपतं आणि पॉझिटिव्ह चालू होतं. ही जर डायग्राम मी अशी थोडी पुढं वाढवली तर इट विल बी लाईक दिस. सो हिअर द फोर्थ cycle also we can show, but I have not shown कारण इथं here it will not be properly visible. So this is modulating signal, this is carrier signal. जर मॉड्युलेशन आपण केलं नाही तर in that case carrier signal will transmit as it is. But what happens when we are doing the phase modulation? Phase of the carrier is changing at this particular point. So here if you consider phase, okay, so it will not, हे जर आपण इथं ह्याचं फेज मॉड्युलेशन केलं नाही तर ही वेवफॉर्म ॲज इट इज पुढं कंटिन्यू होते. सो आय विल ड्रॉ इट. इफ वी आर नॉट डुईंग फेज मॉड्युलेशन इट विल बी ट्रान्समिटेड ॲज इट इज. सो आय विल नॉट राईट हिअर PM और फेज मॉड्युलेशन. आपण कॅरियरच काढू. इथं ह्या पर्टिक्युलर पॉईंटला जेव्हा मॉड्युलेशन होत नाही ॲट दॅट टाईम दिस सिग्नल्स आर मूविंग ॲज इट इज. बट व्हेन द मॉड्युलेशन टेक्स प्लेस और व्हेन द फेज मॉड्युलेशन टेक्स प्लेस, त्या सिग्नलचा फेज हा ह्या पर्टिक्युलर पॉईंट्सला चेंज होतं, जिथं ट्रान्झिशन होतं आयदर फ्रॉम पॉझिटिव्ह टू निगेटिव्ह और फ्रॉम निगेटिव्ह टू पॉझिटिव्ह. सो हाऊ यू विल ड्रॉ द वेवफॉर्म ऑफ फेज मॉड्युलेशन. फॉर एक्झाम्पल इथं असं संपत होतं आपलं आणि आधी काय केलं होतं आपण, सेम सिग्नल we have continued, but here at this particular point this signal will be having phase change of 180. म्हणजे इथं पॉझिटिव्हकडून तो निगेटिव्हकडे जायला पाहिजे, पण तसं न होतं काय होतं या पॉईंटला, अगेन द सेम पॉझिटिव्ह हाफ सायकल इट इज रिपीटेड by considering this point as a origin. That is the concept of phase modulation. So where the phase difference will take place or where the phase is going to change, whenever there is transition in modulating signal from positive to negative. म्हणजे इथं किती पॉईंट्स आहेत, सपोज A, B आणि C. म्हणजे ह्या 3 पॉईंटला फक्त फेज काय होणार आहे त्या सिग्नलचा, it will be shifted by 180 degree, otherwise it will remain same without the phase modulation. So here it is changing by 180 degree, here it is changing by 180 degree. इथं जर बघितलं आपण ट्रान्झिशन तर इथं निगेटिव्ह असणार आहे, इथला कॅरियर ॲज इट इज असणार आहे. सो व्हॉट इज द चेंज हिअर अगेन, इन्स्टेड ऑफ गोईंग इन दिस साईड it will have 180 degree phase shift and carrier of phase modulation, or the signal of phase modulation will be drawn in this way. So this is the concept of the phase modulation. So I hope you are clear with the concept of frequency modulation and phase modulation. So what is the concept in frequency modulation? In frequency modulation, the frequency of carrier signal is changing in proportionate with this modulating signal voltage. So when this modulating signal is having positive half cycle, the frequency of this signal is more. When it is having negative half cycle, frequency of the signal it is less. So that is the concept of frequency modulation. Then the next concept we have seen for phase modulation. So what happens in phase modulation? Phase of the carrier is changing, whereas frequency and amplitude of the carrier remains constant. So what is shown here? Modulating signal, carrier signal. Without any modulation, in this way the carrier is transmitting. After doing the modulation, the phase is changed by 180 degree at the respective points. And again remember, where the phase is going to change in phase modulation, the phase is going to change only at the point where transition takes place from positive to negative or negative to positive. That is the concept of the phase modulation. Now, what is the third type of modulation? In basic analog modulations, that is very important, that is the amplitude modulation. So today at least the basic point we will understand, and in next lecture we will study the three cases of amplitude modulated signals. So there are three conditions to draw the amplitude modulation signal: over modulation, under modulation and exact modulation. That points we will see in the next lecture, but just consider that in amplitude modulation, what is the basic concept of amplitude modulation? Amplitude of carrier signal is changing in proportionate with the modulating signal. So in amplitude modulation, amplitude of carrier signal is changing in proportionate with modulating signal. That is the concept of the amplitude modulation. So as amplitude is changing, frequency and phase of the signal remains constant. So frequency and phase of the carrier signal remains constant, only there is change in the amplitude of the carrier signal. So again in amplitude modulation, there is one term called as modulation index. Why I am discussing these why I am discussing these terms? Because based on the value of modulation index, there are three cases for amplitude modulation, and we have to draw the waveforms for all that three cases in the amplitude modulation. So there is one term in amplitude modulation called as modulation index, and which is noted by the symbol as small m. Modulation index is noted as a symbol small m, and it is given by, it is the ratio of Vm by Vc. So Vm means it is voltage of the modulating signal, and Vc means it is voltage of the carrier signal. मग Vm आणि Vc चा जो रेशो आहे, that is defining the value of modulation index in case of the amplitude modulation. So based on the value of this modulation index, there are three conditions in amplitude modulation. So I will write here, there are three types of AM. There are three types of AM. First one, it is under modulation. First type of AM signal, that is under modulation. In under modulation the condition is m is less than 1. मॉड्युलेशन इंडेक्सची व्हॅल्यू ही 1 पेक्षा कमी असते. सो VM will be less than VC. So when you have to draw the diagram of under modulation, you have to take the value as VM should be less than VC. That is the concept of under modulation. Then next condition, it is exact modulation. So what happens in exact modulation? M is exactly equals to 1. So in that case VM is equal to VC. That is the concept of exact modulation. VM is equal to VC and M is equal to 1. And the third condition is over modulation in the amplitude modulation. So in over modulation what happens? This M it is greater than 1. So M is greater than 1 means by default this VM it is greater than VC. That is the third condition of amplitude modulation. Now out of these three conditions, this over modulation condition is avoided in the communication. Exact modulation, that can be somewhat preferred, but the most preferred communication or best or the most preferred modulation technique in case of amplitude modulation is the under modulation. आपण तिन्ही वेवफॉर्म बघणार आहोत just for your understanding, but always remember after this whatever waveforms of AM you have to draw, that waveforms you have to draw by considering the under modulation condition. मग आपल्याला under modulation condition मध्ये जी वेवफॉर्म मिळेल that waveform only you have to refer hereafter to draw the diagrams of the amplitude modulation. Okay, so this is the concept of the three cases in AM. So once again I am repeating, in phase modulation phase changes, frequency and amplitude remains constant. In frequency modulation only frequency changes, phase and amplitude remains constant. And in amplitude modulation amplitude of the signal changes and only modulating or frequency and phase remains constant. So again in amplitude modulation, based on the value of modulation index, there are three conditions of AM signal. Under modulation, in which M is less than 1 means by default VM is less than VC. So VM is voltage of modulating signal and VC is voltage of the carrier signal. So under modulation means M is less than 1, VM is less than VC. Exact modulation, M is equal to 1 means VM is equal to VC. And in case of over modulation, M is greater than 1 means VM is greater than VC. So out of these three, over modulation is giving more losses, so that is not mostly preferred in this analog communication. Exact modulation, for some of the applications we can go for exact modulation, but under modulation is the condition which is giving good performance if we compare these three types. And that under modulation method of AM is only used for many of the applications in the communication. Okay, so in next lecture we will see how to draw the waveforms for under modulation, exact modulation and over modulation. And then we will see the different types of communication channel. Before considering the types of communication channel, we have to understand what is the need of the modulation. So all these points we will see in the next lecture.